Welcome back. It's Thursday, 1st May. I just paid my bills today. So I'm not going anywhere today because I like to try to make a saving. I like to read this. No, I need to try saving my money on my bank accounts this whole month. Yes, need to close the window. That's 3 different F-15, 3 versions. This F-15 fighter jet. So that's the oldest version. So just read. I just took new paper because this paper is full. This paper is full. There's no room. F-15. I need a minute to do myself ready. Almost ready. Then, wait, I need my blankets. So this is a long read, take like 2 hours to read this.
McDonnell Douglas F-15 Eagle. F-15 redirects here. For other uses, see F-15, disambiguation. The McDonnell Douglas F-15 Eagle is an American twin-engine, all-weather fighter aircraft designed by McDonnell Douglas, now part of Boeing. Following reviews of proposals, the United States Air Force, USAF, selected McDonnell Douglas's design in 1969 to meet the service's need for a dedicated air superiority fighter. The Eagle took its maiden flight in July 1972 and entered service in 1976. It is among the most successful modern fighters, with over 100 victories and no losses in aerial combat, with the majority of the kills by the Israeli Air Force. The Eagle has been exported to many countries, including Israel, Japan, and Saudi Arabia. Although the F-15 was originally envisioned as a pure air superiority fighter, its design included a secondary ground attack capability that was largely unused. It proved flexible enough that an improved all-weather strike derivative, the F-15E Strike Eagle, was later developed, entered service in 1989 and has been exported to several nations. Several additional Eagle and Strike Eagle subvariants have been produced for foreign customers, with production of enhanced variants ongoing. The F-15 was the principal air superiority fighter of the USAF and US allies during the late Cold War, replacing the F-4 Phantom II. The Eagle was first used in combat by the Israeli Air Force in 1979 and saw extensive action in the 1982 Lebanon War. In USAF service, the aircraft saw combat action in the 1991 Gulf War and the conflict over Yugoslavia. The USAF began replacing its air superiority F-15A /B/C/D with the F-22 Raptor in the 2000s. but the severely reduced procurement pushed the retirement of the remaining F-15C /D, mostly in the Air National Guard, to 2026 and forced the service to supplement the F-22 with an advanced Eagle variant, the F-15X, in order to retain an adequate number of air superiority fighters. The F-15 remains in service with numerous countries. Development, edit. Early studies, edit. The F-15 can trace its origins to the early Vietnam War, when the U.S. Air Force and U.S. Navy fought each other over future tactical aircraft. Defense Secretary Robert McNamara was pressing for both services to use as many common aircraft as possible, even if performance compromises were involved. As part of this policy, the USAF and Navy had embarked on the TFX, F-111, program, aiming to deliver a medium-range interdiction aircraft for the Air Force that would also serve as a long-range interceptor aircraft for the Navy. In January 1965, Secretary McNamara asked the Air Force to consider a new low-cost tactical fighter design for short-range roles and close air support to replace several types like the F-100 Super Sabre and various light bombers then in service. Several existing designs could fill this role. The Navy favored the Douglas A-4 Skyhawk and LTV-A-7 Corsair II, which were pure attack aircraft, while the Air Force was more interested in the Northrop F-5 fighter with a secondary attack capability. The A-4 and A-7 were more capable in the attack role, while the F-5 less so, but could defend itself. If the Air Force chose a pure attack design, maintaining air superiority would be a priority for a new airframe. The next month, a report on light tactical aircraft suggested the Air Force purchase the F-5 or A-7, and consider a new higher performance aircraft to ensure its air superiority. This point was reinforced after the loss of two Republic F-105 Thunderchief aircraft to obsolete MiG-17s attacking the Thurn HOA bridge on the 4th of April, 1965. In April 1965, Harold Brown, at that time Director of the Department of Defense Research and Engineering, stated the favored position was to consider the F-5 and begin studies of an FX. These early studies envisioned a production run of 800 to 1,000 aircraft and stressed maneuverability over speed. It also stated that the aircraft would not be considered without some level of ground attack capability. On the 1st of August, General Gabriel de Sauzouet took command of Tactical Air Command and reiterated calls for the FX, but lowered the required performance from Mach 3.0 to 2.5 to lower costs. An official requirements document for an air superiority fighter was finalized in October 1965, and sent out as a request for proposals to 13 companies on the 8th of December. Meanwhile, the Air Force chose the A-7 over the F-5 for the support role on the 5th of November 1965, giving further impetus for an air superiority design as the A-7 lacked any credible air-to-air capability. 8 companies responded with proposals. Following a down select, 4 companies were asked to provide further developments. In total, they developed some 500 design concepts. Typical designs featured variable sweep wings, weight over 60,000 pounds, 27,000 kilograms, included a top speed of Mach 2.7 and a thrust-to-weight ratio of 0.75. When the proposals were studied in July 1966, the aircraft were roughly the size and weight of the TFX F-111, and like that aircraft, were designs that could not be considered an air superiority fighter. Smaller, lighter, edit. Through this period, studies of combat over Vietnam were producing worrying results. Theory had stressed long-range combat using missiles and optimized aircraft for this role. The result was highly loaded aircraft with large radar and excellent speed, but limited maneuverability and often lacking a gun. The canonical example was the McDonnell Douglas F-4 Phantom II, used by the USAF, USN, and US Marine Corps to provide air superiority over Vietnam, the only fighter with enough power, range, and maneuverability to be given the primary task of dealing with the threat of Soviet fighters while flying with visual engagement rules. In practice, due to policy and practical reasons, aircraft were closing to visual range and maneuvering, placing the larger US aircraft at a disadvantage to the much less expensive day fighters such as the MiG-21. Missiles proved to be much less reliable than predicted, especially at close range. Although improved training and the introduction of the M61 Vulcan cannon on the F-4 did much to address the disparity, these early outcomes led to considerable re-evaluation of the 1963 Project Forecast doctrine. This led to John Boyd's energy maneuverability theory, which stressed that extra power and maneuverability were key aspects of a successful fighter design, and these were more important than outright speed. Through tireless championing of the concepts and good timing with the failure of the initial FX project, the fighter mafia pressed for a lightweight day fighter that could be built and operated in large numbers to ensure air superiority. In early 1967, they proposed that the ideal design had a thrust-to-weight ratio near 1:1, a maximum speed further reduced to Mach 2.3, a weight of 40,000 pounds, 18,000 kilograms, and a wing loading of 80 pounds per square foot, 390 kilogram /m. By this time, the Navy had decided the F-111 would not meet their requirements and began the development of a new dedicated fighter design, the FAX program. In May 1966, McNamara again asked the forces to study the designs and see whether the FAX would meet the Air Force's FX needs. The resulting studies took 18 months and concluded that the desired features were too different. The Navy stressed loiter time and mission flexibility, while the Air Force was now looking primarily for maneuverability. Focus on air superiority, edit. In 1967, the Soviet Union revealed the Mikoyan-Gavik MiG-25 at the Domodedovo airfield near Moscow. The MiG-25 was designed as a high-speed, high-altitude interceptor aircraft, and made many performance trade-offs to excel in this role. Among these was the requirement for very high speed, over Mach 2.8, which demanded the use of stainless steel instead of aluminum for many parts of the aircraft. The added weight demanded a much larger wing to allow the aircraft to operate at the required high altitudes. However, to observers, it appeared outwardly similar to the very large FX studies, an aircraft with high speed and a large wing offering high maneuverability, leading to serious concerns throughout the Department of Defense and the various arms that the US was being outclassed. The MiG-23 was likewise a subject of concern, and it was generally believed to be a better aircraft than the F-4. The FX would outclass the MiG-23, but now the MiG-25 appeared to be superior in speed, ceiling, and endurance to all existing US fighters, even the FX. Thus, an effort to improve the FX followed. Both headquarters USAF and TAC continued to call for a multi-purpose aircraft, while both DeSaussway and Air Chief of Staff Bruce K. Holloway pressed for a pure air superiority design that would be able to meet the expected performance of the MiG-25. During the same period, the Navy had ended its FAX program and instead accepted a proposal from Grumman for a smaller and more maneuverable design known as VFX, later becoming the Grumman F-14 Tomcat. VFX was considerably closer to the evolving FX requirements. The Air Force infighting was eventually ended by the worry that the Navy's facts would be forced on them. In May 1968, it was stated that we finally decided, and I hope there is no one who still disagrees, that this aircraft is going to be an air superiority fighter. In September 1968, a request for proposals was released to major aerospace companies. These requirements called for single-seat fighter having a maximum takeoff weight of 40,000 pounds, 18,000 kilograms, for the air-to-air roll with a maximum speed of Mach 2.5 and a thrust-to-weight ratio of nearly 1:1 at mission weight. It also called for a twin-engined arrangement, as this was believed to respond to throttle changes more rapidly and might offer commonality with the Navy's VFX program. However, details of the avionics were left largely undefined, as whether to build a larger aircraft with a powerful radar that could detect the enemy at longer ranges was not clear, or alternatively a smaller aircraft that would make detecting it more difficult for the enemy. 4 companies submitted proposals, with the Air Force eliminating General Dynamics and awarding contracts to Fairchild Republic, North American Rockwell, and McDonnell Douglas for the definition phase in December 1968. The companies submitted technical proposals by June 1969. The Air Force announced the selection of McDonnell Douglas on the 23rd of December 1969. Like the Navy's VFX, the FX skipped much of the prototype phase and jumped straight into full-scale development to save time and avoid potential program cancellation. The winning design resembled the twin-tailed F-15, but with fixed wings. Both designs were based on configurations studied in wind tunnel testing by NASA. An early USAF F-15O, formally named the Eagle upon its introduction. The aircraft's initial versions were the F-15 single-seat variant and F-15 twin-seat variant. After the F-15C was first flown, the designations were changed to F-15A and F-15B. These versions would be powered by new Pratt & Whitney F-100 engines to achieve a combat thrust-to-weight ratio in excess of 1:1. A proposed 25mm Ford Philco GAU-7 cannon with caseless ammunition suffered development problems and was dropped in favor of the standard M61 Vulcan gun. The F-15 used conformal carriage of 4 Sparrow missiles like the Phantom. The fixed wing was put onto a flat, wide fuselage that also provided an effective lifting body surface. The airframe was designed with a 4,000-hour service life, although this was later increased through testing and life extension modifications to 8,000 hours, and some would fly beyond that. The first F-15A flight was made on the 27th of July 1972, with the first flight of the 2-seat F-15B following in July 1973. The F-15 has a look-down forward/shoot-down radar that can distinguish low-flying moving targets from ground clutter. It would use computer technology with new controls and displays to lower pilot workload and require only one pilot to save weight. Unlike the F-14 or F-4, the F-15 has only a single canopy frame with clear vision forward. The USAF introduced the F-15 as the first dedicated USAF air superiority fighter since the North American F-86 Sabre. The F-15 was favored by customers such as the Israel and Japan Air Arms. Criticism from the fighter mafia that the F-15 was too large to be a dedicated dogfighter and too expensive to procure in large numbers, led to the lightweight fighter, LWF, program, which led to the USAF General Dynamics F-16 Fighting Falcon and the middleweight Navy McDonnell Douglas F-4/A-18 Hornet. Upgrades and further development, edit. Main articles, McDonnell Douglas F-15E Strike Eagle and Boeing F-15X Eagle II. The single-seat F-15C and two-seat F-15D models entered production in 1978 and conducted their first flights in February and June of that year. These models were fitted with the production Eagle package, PEP 2000, which included 2,000 pounds, 910 kilograms, of additional internal fuel, provisions for exterior conformal fuel tanks, CFT, and an increased maximum takeoff weight up to 68,000 pounds, 31,000 kilograms. The increased takeoff weight allows internal fuel, a full weapons load, conformal fuel tanks, and 3 external fuel tanks to be carried. The APG-63 radar uses a programmable signal processor, PSP, enabling the radar to be reprogrammable for additional purposes such as the addition of new armaments and equipment. The PSP was the first of its kind in the world, and the upgraded APG-63 radar was the first radar to use it. Other improvements included strengthened landing gear, a new digital central computer, and an overload warning system, OWS, which allows the pilot to fly up to 9G at all weights. The F-15 Multi-Stage Improvement Program, MSIP, was initiated in February 1983 with the first production MSIP F-15C produced in 1985. Improvements included an upgraded central computer, a programmable armament control set, allowing for advanced versions of the AIM-7, AIM-9, and AIM-120A missiles, and an expanded tactical electronic warfare system that provides improvements to the ALR-56C radar warning receiver and ALQ-135 countermeasure set. The final 43 F-15CS included the Hughes APG-70 radar developed for the F-15E, see below. These are sometimes referred as enhanced Eagles. Early MSIP F-15CS with the APG-63 were upgraded to the APG-63 V1 to improve maintainability and to perform similar to the APG-70. Existing F-15s were retrofitted with these improvements. Also beginning in 1985, F-15C and D models were equipped with the improved P and WF-100 PW220 engine and digital engine controls, providing quicker throttle response, reduced wear, and lower fuel consumption. Starting in 1997, original F-100 PW100 engines were upgraded to a similar configuration with the designation F-100 PW220E starting. In 2000, the APG-63 V2 Active Electronically Scanned Array AESA, radar was retrofitted to 18 U.S. Air Force F-15C aircraft. The ZAP Zone Acquisition Program missile launch envelope has been integrated into the operational flight program system of all U.S. F-15 aircraft, providing dynamic launch zone and launch acceptability region information for missiles to the pilot by display cues in real time. Although the Air Force's FX requirements were focused on air superiority, McDonnell Douglas had quietly included a basic secondary ground attack capability in the F-15's design since the beginning and also performed early internal studies for enhancing that capability. In 1979, McDonnell Douglas and F-15 radar manufacturer, Hughes, teamed to privately develop a strike fighter version of the F-15. This version competed in the Air Force's dual-role fighter competition starting in 1982. The F-15E strike variant was selected for production over General Dynamics' competing F-16XL in 1984. It is a two-seat, dual-role, totally integrated fighter for all-weather, air-to-air, and deep interdiction missions. The rear cockpit is upgraded to include 4 multi-purpose cathode ray tube displays for aircraft systems and weapons management. The digital, triple redundant Lear-Siegler aircraft flight control system permits coupled automatic terrain following, enhanced by a ring laser gyroscope inertial navigation system. For low altitude, high-speed penetration and precision attack on tactical targets at night or in adverse weather, the F-15E carries a high-resolution APG-70 radar and lantern pods to provide thermography. The F-15E would be developed into the F-15 Advanced Eagle family, which features fly-by-wire controls. The Advanced Eagle is currently the basis of all current F-15 production. And /APG-63, V3. Beginning in 2006, with the threat of curtailed procurement of the F-22 that was to replace all air superiority F-15s, USAF planned to modernize 179 F-15Cs in the best material condition in order to maintain fighter fleet size by retrofitting the AN/APG-63, V3 AESA radar and updated cockpit displays. The first upgraded aircraft was delivered in October 2010. A significant number of F-15s were equipped with the joint helmet-mounted cueing system. Lockheed Martin developed an infrared search and track (IRST) sensor system for tactical fighters such the F-15C, eventually resulting in the AN/ASG-34, V1 IRST-21 sensor mounted in the Legion pod. The AN/AQ-33 Sniper XR pod was also integrated as a makeshift interim IRST solution. A follow-on upgrade called the Eagle Passive Forward/Active Warning Survivability System, EPORS, was planned. Boeing was selected in October 2015 to serve as prime contractor for the EPORS, with BAE Systems selected as a subcontractor. The EPORS is an all-digital system with advanced electronic countermeasures, radar warning, and increased chaff and flare capabilities in a smaller footprint than the 1980s-era tactical electronic warfare system. More than 400 F-15Cs and F-15s were planned to have the system installed. In September 2015, Boeing unveiled its 2040 Sea Eagle upgrade, also called Golden Eagle, designed to keep the F-15 relevant through 2040. Seen as a necessity because of the low numbers of F-22s procured, the upgrade builds upon the company's F-15SE Silent Eagle concept with low observable features. Most improvements focus on lethality, including quad-pack munitions racks to double its missile load to 16, conformal fuel tanks for extended range, Talon-Hate communications pod to communicate with fifth-generation fighters, the APG-63, V3 AESA radar, long-range Legion IRST pod, and EPORS electronic warfare suite. The 2040 C upgrade for the F-15C/D was not pursued, owing to the airframe's age that made it not economically sustainable, but many of the components such as EPORS and AESA radar were continued for F-15E upgrades as well as new-build F-15X Eagle II ordered by USAF in 2020. The F-15X took advantage of existing Advanced Eagle production line for export customers to minimize lead times and start-up costs to replace the remaining F-15C/DS, whereas F-22 production restart was considered cost prohibitive. Design, Edit. Overview, Edit. The F-15 has an all-metal semi-monocoque fuselage with a large cantilever, shoulder-mounted wing. The wing planform of the F-15 suggests a modified cropped delta shape with a leading-edge sweepback angle of 45 degrees. Ailerons and a simple high-lift flap are located on the trailing edge. No leading-edge maneuvering flaps are used. This complication was avoided by the combination of low wing loading and fixed leading-edge conical camber that varies with span-wise position along the wing. Airfoil thickness ratios vary from 5.9% at the root to 3% at the tip. The empennage is of metal and composite construction, with twin aluminum alloy /composite material honeycomb structure vertical stabilizers with boron composite skin, resulting in an exceptionally thin tailplane and rudders. Composite horizontal all-moving tails outboard of the vertical stabilizers move independently to provide roll control in some flight maneuvers. The horizontal tails have a dogtooth notch to mitigate flutter. The F-15 has a spine-mounted air brake and retractable tricycle landing gear. It is powered by two Pratt & Whitney F-100 axial flow turbofan engines with afterburners, mounted side by side in the fuselage and fed by rectangular inlets with variable intake ramps. The cockpit is mounted high in the forward fuselage with a one-piece windscreen